Data protection is a top priority with today's work-from-home workforce. However, current data loss prevention tools inadequately protect data in cloud or SaaS offerings from insider threats. Secure Circle automatically protects data as it leaves SaaS services such as GitHub, AWS, and Salesforce. The protection is transparent to users and works with any application to persistently protect data, even source code. Secure your data with Secure Circle's Zero Trust Data Protection. Begin your 30-day free trial by visiting securityweekly.com/Secure Circle. Crowdstrike stops breaches. These days, critical work isn't done from the protection of a corporate network. It happens at cafes, back offices, and at home. New ways of working mean new attacks. New attacks require new defenses. Crowdstrike stops breaches so you can do what you do best. Crowdstrike, we stop so you can go. Crowdstrike is offering Security Weekly listeners 15 days free access to its platform. See how it works at securityweekly.com/Crowdstrike. Well, welcome back, everyone, to Enterprise Security Weekly. We are ramping up our webcast and technical training schedule. In our next webcast, you'll learn how to reduce the blast radius of your cloud infrastructure. Visit securityweekly.com/webcasts or to subscribe, register for, rather, what we have coming up, and securityweekly.com/on-demand to get the previously recorded webcasts. I would like to welcome, actually, first, before I do that, the Cloud Bees was Jenkins. That's what the underlying technology was there. So more on that later. But now I would like to introduce Edward Wu, who is the AI and ML lead at ExtraHop, responsible for research and development of all things AI and ML products and capabilities. Ed, welcome to the show.
Thank you for having me.
Ted Driggs is a seasoned and customer-focused product manager with a background in enterprise IT, community building, and cloud-native security. Ted, welcome.
Thank you for having me.
Welcome back, I think it's your second ESW interview. Yes. Outstanding. So we want to talk about, obviously, AI and ML, and I think a good place to start is what is this technology at a very, very high level, and very briefly, what's the difference between the two, and what are some of the kind of misconceptions, right? I think is a good place to start.
Yeah, so AI and ML are attempts to mimic human intelligence in a computer. So we don't fully understand the theoretical nature of human cognition, but we understand more and more pieces about how to mimic that intelligence for useful outcomes. The two terms are largely used interchangeably outside of academic contexts. And for a long time, there's been a lot of hype around AI and ML that has led to it almost being a dirty word in security for several years there. I remember, I want to say it was RSA 2018, you could not walk down a single aisle without being attacked by those four letters. But they now their time has come, and they really are making attacker and red team lives a lot harder, which is exciting.
Yeah. So I also, Ed, I want you to weigh in on, especially with your background, and tell us about how you first thought of applying AI and ML, maybe independently or together, to solve cybersecurity problems.
Yeah. So in order to apply AI ML for cybersecurity, I think there are a few areas where, to some extent, I think can provide a lot of value. For example, one challenge with cybersecurity is the lack of trained, the talent shortage. And as part of that, obviously, a lot of vendors, including us, have been working very hard at applying AI ML for detection, specifically, not only kind of, you can say, detecting common attack signals or leveraging known indicators of compromise, but also identifying and being able to identify behavioral detections or behavioral anomalies that might correlate to suspicious behaviors. Because frankly, nowadays, attackers are leveling up their game in the sense that they are trying to mimic benign users within the enterprise in order to stay off the radar. And they are not, they are more and more frequently, they are trying to stay away from using or exhibiting obviously malicious behaviors in order to, you can say, stay stealthy on the east-west corridor. And that's one area where AI and ML can outperform a lot of the existing technologies because of this ability of AI ML to intelligently infer and understand the context of behaviors it observes.
Yeah, I think we broke that right. Scalability and context are two of the key challenges, right? Matt, you had a question.
Yeah, I'm trying to differentiate like use cases for machine learning where a machine is learning patterns, I think, where versus use cases for artificial intelligence where you're trying to understand behavior that might take some of the machine learnings into account. Is that a good way to think about the difference between ML and AI?
Yeah, I think that's certainly one way you could think about that. Obviously, AI and ML, I feel like in the last few years, the terms have been hyped to an extent where the definition are quite blurred, frankly. But technically, to some extent, AI is, to some extent, the end goal, while ML is one path a company or a technology could take to reach AI. So ML mostly talks about using statistical methods to have computers intelligently learn, while there are other, you can say, paths or ways one can achieve AI that doesn't involve that. For example, when we are playing chess or when somebody is trying to automate playing chess, one could actually do that without utilizing any of the machine learning, simply by essentially asking the computer to brute force all the possible chess moves and scenarios. So that's another way where one could achieve AI, but obviously in this case without leveraging ML. But for cybersecurity specifically, I would say majority of the time, in order to achieve some sort of intelligence, ML is required.
Got it. And that goes back to, I think, Paul's original discussions around some of that scale issue, right? Is because there's so much data to process that machine learning helps us really extract some intelligence out of that we can then apply into an artificial intelligence model, right?
So I think that there's two layers to the scale problem here. There's the amount of data that is being generated by the production system and the number of features or attributes that can be extracted from that in real time and need to be compared against whether it's known bad lists or known good lists to form the most primitive building blocks for ML. That alone is overwhelming for most humans. On top of that, the number of policies that we're trying to infer or to understand from the organization that the organization may not itself understand really sort of forces us to use ML to accurately build a model of the way the world is, which is important for any attempt to detect when the world is changing or incorrect.
Is it largely helping us understand the context and relationships between events in a cybersecurity context?
Events and entities.
Yes, well put. Ed, you had a lot more insights, which I really appreciated as we kind of dig into this topic as to exactly how this happens, right? When you apply this technology. So I'd like to hear more about like basically how this is done, which I often think we don't talk about enough. Like how is this actually done in a cybersecurity setting?
Yeah, so when somebody is looking at kind of applying AI ML on cybersecurity challenges, I guess the first step will be to identify what kind of problem you're trying to solve. For example, obviously detection is one area, especially behavior detection, I think comes up as like the natural first choice. But in addition to that, there are actually a few other areas one can apply AI ML as well. For example, one area would be inference. Like Ted and I think both of you guys also mentioned earlier, context is very important to distinguish between benign behaviors and malicious behaviors on the network. But unfortunately I would say most of the time, these contexts are not digitized or they are not written down. They exist in customers or operators' heads. And that makes a lot of times detection or cybersecurity quite challenging, because when we are talking to customers, a lot of times we often hear things like, hey, if I didn't know John or what he was doing, this will be very suspicious. And the contexts like that are critical to enabling security teams to quickly diagnose and triage detections. And that's also one area actually AIML can help, because by monitoring how different entities and devices on the network behave, AIML can actually intelligently identify things, for example, like high privileged users on the network, or high importance servers that power the business units. And in addition to that, inference and detection, I would say investigation and prioritization is another area where AIML could help to automate some of the mundane tasks that SOX team are kind of performing today. For example, a lot of times when somebody sees a potential breach, the first thing the SOC analyst looks at is, what happened in the 5 minutes before the detection? For example, did the user clicked into a new website? Did user opened up a new email? And a lot of these, you can say, investigation steps are quite manual. And that's another area where AIML could help by automating these investigation or context gathering steps.
Yeah, and as an analyst, I've been there so many times, right? Where you see an artifact or something on the network, and you're like, that's an event, but it depends on what happened right before that, right? If it was something that I expect, then okay, that's fine, right? But if it's something that I, as a human, determine could be risky behavior, then that changes my investigation. Kind of going the other way too. If I see a user, John did some high privileged activity, right? Maybe added a user into the domain admins group. I'm like, was that normal? Like, I know John's here, like we had coffee this morning, right? Like that kind of stuff plays into it. And then you're like, was there a ticket for that? Was there a change request? And so many times in my career, like I've gone back manually and tried to pull all the data together to go, was that event something we expected or not, right? And I think this is where AI and ML technologies can really help us make those decisions, help correlate those events, artifacts, roles, and people together to identify that, that user going in the domain admins group, that's a red flag. You should pay attention to that, without me having to go investigate it manually. Did I capture that correctly, Ed?
Yeah, absolutely. I think you captured it very well. A lot of times it's funny that to some extent the existence of a ticket a lot of times differentiates a malicious behavior that IT teams are performing versus a serious attack or breach of the network. And that's definitely some of the areas where AIML could help by inferencing what different users or what each entity on the network should be performing. So we can, to some extent, you can say, extract the domain knowledge that operation teams have in their head.
Mm. Yeah.
Right. Because
go ahead.
One of the ongoing challenges is that the businesses cannot tolerate a lot of added friction, or they won't tolerate a lot of added friction from security. So security teams do frequently find themselves not being in the loop on changes before they happen, and then having to go back and do that reverse engineering of, was this intentional and nobody told me, or was this malicious? And that's somewhere else where AIML, even before it can make that determination, can skip over a lot of the work needed to put the right things in front of a person.
Yeah, and that's I've often found that to be some of the differences, right, between some of the free and or open source things and the commercial product offerings and solutions that have data scientists such as Ed working on the product is, an unsophisticated product will tell me, like, here's all your top talkers on the network as an example. Like, this host sent more traffic than everyone else, right? And it's up to me to determine and have the intelligence to go, is that normal or not normal, right? But I think the point that we hit on, we were prepping for this, right, was in another organization, that decision is a completely different scenario. That could be normal or not normal, and that's going to vary from organization to organization, yet there are solutions that are treating that the same, right?
Well, so let's look at a more concrete example, something like PS exec.
Yep.
With PS exec, it depends so much on the history of both the commanding device and the command recipient, on the services that are being invoked, on whether those services are common from that sending device, to other devices on the network, indicating this might be regular administrative function. But on top of all that, you also need to look at the commands that are being run and at the legitimate uses and potential for misuse of those commands. So ideally, you want to combine all of the ML-derived context with subject matter expertise to learn new environments, but to avoid finding really unhelpful but mathematically correct outcomes. So it's a really interesting multifaceted problem in that regard.
And it's interesting. I think that AI and ML technologies, in addition to humans, it's interesting how they play into the scale, right? I described the scale before. We haven't talked about it in a while, but if you rank all of your events on your network or systems on a scale from 1 to 10, 1 being the most benign and really easy thing to recognize, happens all the time, totally benign. 10 being we need to drop everything and respond to this incident because we're hacked, right? I think like 1 to 3, maybe 8 to 10 are easy for probably both, even unsophisticated solutions and humans to recognize. It's that 4 through 7 in the middle that we spend a lot of time determining, is this something that requires a response and what level of response, right? And I think that's really where a sophisticated AI and ML-based solution can really help. Ted, you kind of agree with the kind of how we section it off?
Yeah,
absolutely.
Sorry, go ahead, Ed.
Yeah, so I think you made a really good point. And nowadays, I would say more and more attackers are trying to stay off of the 8 to 10.
Yeah.
And they are trying to, you can say, sneak in or try to hide under the radar within the 4 to 7 range, where to some extent, where the behaviors are more difficult to infer the original intention. And a lot of times that's definitely where AI ML outperforms, you can say, traditional solutions.
Oh, I lost Ed's audio there. I don't know if that was on his end or our end. Oh, I'm seeing messages on his screen. Oh, Ed, sorry, we lost your audio there. If you want to kind of start over on that last bit, and also I think your microphone might be rubbing on your shirt too. So maybe just hold it out from your shirt a little bit.
Apologize for that. Yeah, can you hear me now?
Yes.
Yeah.
Cool. Awesome. I was talking about the attackers are trying to are leveling up their game, and they are trying to quote unquote stay under the radar. And so a lot of the newer techniques, especially around the lateral movement, are designed to blend in, so the behaviors will not bubble up at, you can say, the 10 to 8 range, but rather they will look like kind of or potentially benign behaviors within the 4 to 7 range. And that's where AI/ML could help a lot, because its ability to infer different roles, privileges, behavior patterns of different entities on the network.
Is that where some of the different types of models come into play? Because at the extremes, there's certain things, certain patterns you can look for, and they're easy to detect. How do detections and approaches change in that 4 to 7 range? How do the models shift to cover some of those? It looks benign, but it's really malicious scenarios.
Yeah, that's a fantastic question. And to some extent, that's one of the biggest challenges, or at least the technical challenges with applying AI/ML to cybersecurity. Because a lot of times, in order to identify these behaviors within you can say the 4 to 7 ranges, one needs to utilize what we call unsupervised learning. And one challenge with unsupervised learning is it is great at identifying mathematical anomalies, but unfortunately, not all mathematical anomalies are actually malicious attacks or potential breaches. So there are additional technology one needs to build to some extent on top of the unsupervised learning models and algorithms to differentiate between benign anomalies and actual the malicious anomalies. And that's where, to some extent, a lot of the inferencing comes to help, because by being able to infer the roles, the privileges, the behavioral patterns of different entities on the network, that really helps the unsupervised models and algorithms to differentiate and only alert on the potential breaches.
Right. Because the challenge is you don't want to create a bunch of false positives, because all you're doing then is overwhelming the SOC analysts with events that aren't malicious. Therefore, we just kind of defeated the purpose of AI and ML in the first place, which was to help the human to scale.
Yeah, made more work for ourselves. Yeah.
Well, one other thing that I want to call out that Edward just mentioned there was the interconnection of multiple models. So when we talk about inference of roles or activities in the network, that's an entire robust ML space unto itself. Then there's another robust space which uses that as its inputs, or uses inputs that are the outputs from those algorithms in order to do the next layer of detection. So these techniques sort of can be applied, different techniques can be applied in sequence or in parallel to produce usable output. But that's another one of the big kind of areas, is you can't take the same models and apply them to everything and expect good results. You have to tailor the ML that you're using to the problem that it's being asked to solve.
Right. So an unsupervised model potentially needs data from a supervised model to infer whether it's benign or malicious. And so there's a kind of an interdependency between those different types of models.
It's also a really good, so from a product perspective, it's a really good touch point for correcting the ML, right? So if you have some sort of inference, like what is this thing supposed to be doing? If your supervised ML doesn't get that right the first time, that's a good opportunity for the analyst or the SOC engineer to step in and adjust the data, which will improve future runs of the supervised algorithm, but will also make sure that the unsupervised algorithm still has good input information.
And speaking of the different, kind of data types you might be working with and sources in how your strategy might differ, Edward, you very much described my enchanted quadrants, right, earlier, right? It's you pull from logs, you pull from endpoint, you pull from network. I had threat intelligence as the fourth source. But how do we apply, and what are the pros and cons of applying these methodologies to the three different sources being, logs, network, and endpoint?
Yeah, that's a fantastic question. I can start with logs. So logs, the biggest challenge around applying AI/ML to logs is normalization. Unfortunately, logs are not standardized, which means, for example, HTTP logs from one implementation of HTTP server like Apache often look quite different from ones from another HTTP server implementation like IIS. So the normalization makes application of AI/ML really difficult. And in addition to that, if we talk about endpoints and network data sources, I would say both of these data sources provide relatively normalized inputs that are relatively, or comparatively speaking, easier to apply AI/ML to. But in order to compare these two, in terms of the quantity, I would say network definitely provide a broader coverage, just because, for example, installing a single TAP or span ACK sensors on the network can frequently, often enable visibility into thousands or tens of thousands of assets in the enterprise. Well, in comparison, obviously, endpoint requires installation of agents on every single asset. So I would say in terms of quantity of the data, network definitely provide a wider coverage and a bigger breadth, which is great because kind of circling back to inference and detection, the more assets the AI ML algorithms and models can see, the better of a job it will be at in terms of understanding what everything should be doing, and understanding things like the roles, the privileges, the behavioral patterns.
Yeah, it's interesting because it got me thinking about the kind of challenges we have as we move through all these different sources, right? Logs, certainly the different formats present challenges, right? When we move to the endpoint, you can have lots of different similar challenges in terms of the number of formats, right? If we move to NetFlow even, which is network telemetry, there's even a lot of differences in those formats too, right? When we get to full packet capture, we start to have a really standard set of data. We know in the offset of the packet where source and destination IP lives, right? Where that information lives. And to your point, Edward, right? We can build models on that more accurately and have an accurate source of truth. And I think it's a great way to think about like why we always say like the network packets never lie, and why us as analysts, we love packet data. It's a great way to frame that because it is the most standardized way. Now, not saying that there aren't differences in the way people have implemented their TCP/IP stacks. We know that, but I think it's much less. It's the best source of truth that we have, given all those different sources.
Absolutely.
And ExtraHop does a great job of giving us visibility into that. So that's a great segue into. Is there any other product-specific things that you wanted to kind of round out our discussion with as to how this is implemented inside of ExtraHop's product? We've seen some great demos, and this was a great conversation, I think, to kind of lead us to how this is done inside of a solution.
Yeah. Go ahead, Ted.
Thanks. So one of the items that ExtraHop's done is we move a lot of the heavy calculation to the cloud in a way that preserves customer privacy, but that allows us to take advantage of the bursty nature of a lot of these analyses. So we're seeing other vendors do the same thing, but from an architecture perspective, we think that the combined sort of center and edge model is going to be crucial, both for scale and taking advantage of the cloud, but also for the network effects that can come from attackers. Attacker mistakes in one customer environment can burn ongoing attacks in other environments by leveraging those effects. And that's something that we're really happy about from an architectural perspective, and that we think is going to be important to many security products over the years to come.
And what I also love too is that you're preserving the original full packet captures, right? We've seen in many of your demos, you can dig into that data. And one thing that we learned in a previous segment this week is the dangers of doing that normalization of the data. In that data normalization, you can lose artifacts. And if you're not storing the original logs or whatever source of that data was, by normalizing it, you can lose some of those artifacts that you may need to refer back to in incident response, for example. I think it's another reason why we really love network packet captures and preserving that original data, because it's all there if we need to go back to it.
So now that you've said that, I want to jump on a soapbox for 1 second and call out that if you do upstream decryption before you feed the traffic into your network analysis tools, the traffic you're analyzing in those tools is not the original traffic, right? So we've seen some things that will sort of move the decrypt to be a span ACK concern or some other system, and will create these unencrypted packets for other tools to analyze, but those weren't the real packets.
Right.
So it's really important there that if your goal is to have that full fidelity, that you have a tool that's actually capable of doing the analysis on the original and is not relying on something else in the middle.
That's a great point. That's awesome. I love this. I learned so much from you folks on this discussion, on the prep call in this interview. So I wanted to thank you for that. And any closing thoughts or things you want to tell our audience? Folks that want to learn more, you can go to securityweekly.com/extra hop. Edward and Ted, thank you very much for appearing on Enterprise Security Weekly.
Thank you for having us. It's a pleasure.
With that, we'll take a short break and come back with our final interview for this show with Jeff from Secure Circle. Stay tuned.